All right, welcome back to Daily Shy, Daily Life, Daily Math, Daily Science, learning something new every day. Here we go. We are doing beginner algebra work. In the last video, we were doing some like multiplication of fractions, and continuing on with this, remember we also had mixed numbers. So in this video, we're gonna multiply two mixed numbers. This comes from section 1.1, example number 3, and this is example like 3b. Okay, so we still have these fractions, but in this one, we're going to do a mixed number. And they give us some of the work already in the book, but we're going to find this ourselves. I want to show you how we found this. So recall that a mixed number, I'll do the 2 and 1/3 one. Recall that a mixed number is the same as saying 2 plus 1/3. Interesting. And maybe or maybe not, do you recall that a number divided by 1 is just the same thing as saying the numerator? So 2 divided by 1 is just 2. And maybe, or maybe not, do you recall that you can't add fractions together unless the denominators are the same? Now, it would be far easier to turn this fraction to have the same denominator as this fraction than the other way around. And the reason is because we can just multiply 1 by 3 to get 3. Okay. And we saw in an earlier video that multiplying a fraction with the same numerator and denominator doesn't change the value. Therefore, I can multiply 2 by 3 to get the numerator and 1 by 3 to get the denominator, and that will still have the value of 2. Pretty cool. All right, so that's interesting. Not sure why that's happening. Okay, so there we go. Let's do that work. Let's do 2 times 3. That's 6. If we add 3 together twice, we get 6, and that's the same thing as saying 2 times 3. I already said 1 times 3 equals 3. Any number times 1 is just that number. All right, and then we have 7 over 3. Because when you add them, at this point, you only keep the denominator the same. You'll add across the numerator to get the 7. And that does match the answer that they gave us earlier. Just to make ourselves really confident with the material, let's also do the mixed number 5 and 1/4. So that's just saying 5 plus 1/4, which is just saying 5 times 4 over 1 times 4 plus 1/4. You never want to like forget what you're doing in the whole problem. And as the videos go on, I'll probably write fewer of the intermediate steps, but I want you to understand what I'm doing. So 5 times 4 is 20. Therefore, 20 divided by 4 will give us 5. But we want to add these together. And anyway, that's how they got the 21 over 4. Cool. So the original problem had us multiplying these fractions together. And so that's what we're going to do in the next step. And before we actually multiply them together, if the goal is to have it in the lowest term possible, then we might just want to kind of inspect the numbers first, but to see if there is already presenting some common factors. So one way to do it is to just pick one of the top numbers. Let's pick 7 since that's the first one, and then look at the bottom numbers and see, is there any common factor between 7 and 3? None that I can think of other than 1, which doesn't help us because we want to be able to reduce this. So 1's not going to help us reduce anything because we already know that 1 divided by itself is just going to be 1. What about 7 and 4? Again, no, there's no common factor between 7 and 4. 4 is an even number, 7 is not an even number. So I wouldn't expect a common factor to begin with. Turns out that 3 and 21 have a common factor, but even if you didn't know that, there's a little trick with 3's in that if you take a number, in this case 21, and if you add their digits individually, so long as the sum of their individual digits equals 3, then it is divisible by 3. And that's just a little trick that we'll probably use many, many times. So I just wanted to show you that. It turns out that 21 does have a factor of 3. So what goes with the 3? We're going to need 7 3's added together to give us 21. And then, of course, 3 and 1 factors. And 3's are common factor between those two numbers. Cool. So I'm going to rewrite the numerator to be 7 times 7 times 3, right? Because that's pulling out the common factor that we want, which is 3. And I'm also going to rewrite the denominator just in an order where I can see those 3's on top of each other. So I'm going to write 4 times 3 instead of 3 times 4. Cool. And now we can use that basic principle of fractions. Remember how these can kind of break apart? And when you see the same number above itself, by itself, it's equivalent to saying 1. And for our purposes, we'll just ignore it. Because by the basic principle of fractions, this holds the same value. We're almost done with our reduction. Well, I guess technically the reduction is done. We now consider 49 over 4 as an answer, but this is an improper fraction. And in most cases, you're going to have to continue to manipulate this problem until you have a proper fraction or a mixed number. So how do we work with 49 over 4? Because there's no common factor in it. There's a little trick we can apply. First, let's recognize that 49 is just the sum of 40 and the number 9. That's one way of doing this. And this is the same as saying 40 over 4 plus 9 over 4. And 40 and 4 do have common factors, right? We can split 40 up into 10 and 4. we can consider 4 is simply 4 and 1. And so we can rewrite this, that's an equal sign. We can rewrite that as 10 times 4 over 1 times 4, or more simply just 10, because the 4's will cancel out and 10 over 1 is just 10. What about the 9 over 4? It's still an improper fraction. So even though this is true to our problem, it's still not like fully reduced, fully proper mixed number, that sort of thing. So let's do a similar thing to 9 over 4 that we did before. What if we looked at 9 as simply being the sum of 1 plus 8? Then we have 8 plus 1 over 4, which means that we have the fraction 8 over 4 plus the fraction 1 over 4. 8 and 4 have common factors, that being 4. And so we can consider 8 as the product of 2 and 4, 4 as the product of 4 and 1. And like we did up above, we'll rewrite 8 over 4 to be 2 times 4 over 1 times 4, or simply 2. Don't forget this. 1 over 4. And don't forget the 10. Easy to do, but there is going to be a 10 plus the 2. So I kind of jumbled this up. Hopefully you could follow what I was doing. But I treated each of these separately. So first I did like the 40 over 4. That's how I got the 10. And then I did the 9 over 4. That's how I got the 2 and 1/4 over here. Oh no, I'm erasing instead of writing. That one. So, whoops. That's how I wind up with 10 plus 2, 1/4, which turns into basic arithmetic. 10 plus 2 is 12. And that is fully reduced mixed number proper fraction from way up above, where we had this multiplication happening. Now we know it's just 12 and 1/4. Good job. All right.